Factor mania!
All right, 8.5, factoring x squared plus bx plus c. So the biggest thing here that we are going to be working with is factoring. And why do we factor? So when we are working with any sort of problem with an x, what is our main goal? To find the value of x. So if we had, say, x plus 5, and we have an equation and it says this, right? This is the simplest, very simple expression or equation, right? Where I need to undo what's being done to x, right? So I subtract 5 on both sides and x is equal to 2, right? Now, if I have x squared equals 49, how do I undo the x squared, right? I find the square root of it. And then I have to do that to both sides. So x is actually equal to positive or negative 7, right? Because positive 7, if I put it into that original equation, will get me 49. If negative 7 times negative 7 will also get me 49. Now, what if I have x squared plus 2x plus 3 equals 6? How do I solve that? Well, I want to get x by itself, but I have terms that are not alike. I can't combine them, right? So that's our goal is to, that's why we are factoring. We're factoring so that we can get x not to be squared. We want to get a single x, and we actually want two binomials. Okay, so, and I'm not going to use this an example. I'm going to use one of our prior examples. So let's do like x plus 1 times x plus 3. So we know that we can FOIL this, right? First times first is x squared. Outside is 3x. Inside is 1x. Last is 3. Okay? So now I'm going to combine my like terms, so 4x plus 3. Here, if I had this and it was set equal to 0, could I find out what x is? I can, if I know how to factor it. So with factoring, we're going to take this and we're going to turn it into two binomials multiplied by each other. And we're going to use some tricks to try and remember how to do that. And we're going to get to a point where it's x plus 1. So instead of writing it this way, I'm going to write it this way, x plus 1 times x plus 3, and it's equal to 0. And this is further down the road into an algebra, but we know that if this is equal to 0, right here, then anything multiplied by 0 is going to equal 0, correct? So if I put, what would I put in for x for this whole thing to be equal to 0? What plus 3 equals 0? Negative 3. So using this rule, the multiplication of 0 rule, I mean, you would set actually both of your binomials set equal to 0. So x plus 3, Taylor, you're going to be, if I go off my page, you have to let me know, okay? Okay. I'm actually going to solve for x, but just this binomial. So x is equal to negative 3. So now, if I put negative 3 into this equation, it should equal 0. So I'm going to put negative 3 in here. Negative 3 times negative 3 is 9, plus 4 times a negative 3 is negative 12 plus 3. 9 plus negative 12 is a negative 3 plus 3. Does that equal 0? It does. Now this is down the road. We're not actually solving for x. I'm just showing you or telling you why we are doing what we're doing in this lesson. Okay, our goal is to be able to solve for x later. But first we need to learn how to factor. And factor means that we need to come up with two binomials that make up that trinomial. So instead of multiplying our two binomials, we're going to break up a trinomial and make it two binomials. So let's just go to the beginning. Okay, so first I can factor trinomials with the leading coefficient of 1. That means that I don't have a coefficient other than 1 on my x squared. Those are going to be your easiest ones to factor. First, what are factors? What are the factors of 48? Okay, 1 and 48. 2 and 24. 3 and 16. 4 and no 5, no 6. Wait, 6. 6 and 8. No 9, no 10. I think that's it, right? And then we've already wrote that. Okay, so what are the factors of it? So we're going back to the basics of what are factors. So factoring means that we are going to factor this expression or this trinomial to two things that when multiplied together, your result is that trinomial or something that looks like this. Okay, so factors of 64, 1 and 64, 2 and 32, 3, no, 4, no, wait, yeah, 4, 4 and 16, thank you, and 8 and 8. 8. So knowing the factors, we need to know how to factor first and foremost. The factors of. What if this was 72x? What are the factors of 72x? 72 and x. Same thing. So then we have also 1 and then 2 times 36, 3 times 24, 4, 5, then 9 and so we understand the concept of factors, right? Okay. Now, the rules for factoring trinomials. So trinomials are 3 terms with a leading coefficient of 1. First thing you want to do is you're going to factor the, what do you think? Huh?
Like
Factor the first, no, sorry, not the first term. Sorry, the third term. Yes. Okay, if all the terms are positive, your factors will both be
negative.
addition. Meaning your binomials will both be adding in them. Okay, if your third term is positive, and your second term is negative, your factors will both be subtraction. And if your third term is negative, your factors will have, what do you think? Different or opposite sides. Signs, sorry. Opposites. Opposites. Not opposites. Opposite signs. I know. Okay, so you're going to find the factors that multiply to the first term and add to the second. Okay, so find two numbers or variables that multiply together to get to third term and add to get to the second. What that means. So find the factors that multiply to the third term, and I'm going to also add to the second. Now this is a lot of stuff that doesn't make sense until you get working with them. Okay, so it's just a reference to come back to. So we are going to, there's, well, a few different ways to do it. There is a table method and the X method. So you want to find the factors of the third term that add up to the second term. Lexi? Factors of the third term that add up to the second term. That's what we're looking for. So factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now, the sum of the factors when I add them up, so 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. And 4 plus 6 is 10. So when multiplying them together, the two numbers, they have to come up with 24, and then you want them to add up to that middle term. Okay, so factors of 24 that add up to 11. That's what I'm looking for. So 3 and 8 added together gets me 11. So when multiplied, we want to get that 24. When added, we want to get that 11. And the two numbers that work are 8 and 11. Or 8 and 3, I'm sorry. Because they multiply to get to 24. They add to get to 11. So now, once we get past that first initial trying to figure out the factors of 24, the third term, that add up to that 11, or the second term, we need to write it as a new two binomials. Yes. Huh? Oh, yes. Yes. But a lot of the times it will. They will. So I'm going to do x plus 8 multiplied by x plus 3. This is my goal, to get two binomials. When multiplied by each other will get me this. And I should have written the r, not x. So it should be r plus 8 multiplied by r plus 3.